Hi everyone, Ms. Kilroy here. Today we're going to learn about chemical reactions. So on your C-note paper at the top of the page where it says topic, please write down chemical reaction indicators, and then our essential question is, how do we know if a chemical reaction has taken place? So if you think I'm going too fast anytime, feel free to pause and then you can write all of this information down. You have to write down everything that I typed in white. Please write it on your paper. All right, here we go. Okay, so on our first line of notes, please write down there are 4 indicators or clues that a chemical reaction has taken place. So we're going to be talking about 4 clues that tell us if a chemical reaction has taken place or not. And the first indicator, the first way we know if a chemical reaction happened, is if a gas is formed. So in this example, there's a liquid and a solid. Combine them together and it makes these bubbles or this gas. So when a gas is formed, that's one way we know.
Are you ready to imagine it? This one is so huge, Carl had to blow the lid off the place. We're out in front of the IS, the Imagination Station, not to be confused with the ISS, but I think they might see this from space.
Maybe.
Carl, what are you cooking up?
Well, today we're going to talk about hydrogen peroxide. It's the stuff you have in your medicine cabinet, right? You pour it in a cut and it bubbles. And the reason it bubbles is because the hydrogen peroxide, H2O2, comes in contact with catalase in your skin, which breaks down the hydrogen peroxide, turns it into basically water and oxygen gas. Okay? So,
I can say okay, but you lost me.
yeah, well, let me show you what happens here. So this is just a bigger scale version. This here is 3% hydrogen peroxide. What we're using over here is 35.
Oh.
So it's much more concentrated. I have a catalyst in here, sodium iodide, and we're going to pour that into the hydrogen peroxide just to see what happens. Okay?
Sure.
Because it should catalyze it and cause it to break down. So I'll pour a little
Let's
in.
just see.
Step back.
Whoa.
Yeah.
Catalyzed all over.
And look at that steam, right? This is an exothermic reaction. All right, so we're generating heat. We generated lots of oxygen gas there. But for me, it was a little disappointing because I really want to capture those bubbles in some soap.
Of course you do.
And then we can make a foam. Okay? So same deal here. We've got some hydrogen peroxide, 35%, some Dawn dish soap. I'll just add the dish soap into there. And I'm going to give you the honor this time, Tony.
Excellent.
Of adding the catalyst. Now, wait just 1 second. I'm going to take the cap off. I'm going to give this to you. Let me swirl this around a little bit. Hydrogen peroxide, soap, catalyst. Go ahead and pour it in. Let's see what happens. Just dump the whole thing in. We release the oxygen inside, and you can see we generate lots of foam. It's a giant blob of oxygen-filled, soapy foam,
Yeah.
which is really cool.
It is. It's like Ghostbusters 2.
Exactly. But now, I want to take this one step further. I want to change another variable here. Instead of doing this in a big graduated cylinder, I have set up down here 6 flasks, which taper near the top. And what I'm hoping for here is that, and it's going to go for a while. What I'm hoping here is that as we generate this gas, it is going to generate some pressure. And inside each of these flasks, we should get a jet of foam shooting out. Okay? But one more thing. Everybody knows Roy G. Biv, right?
Right. We're going to go the rainbow color.
We're going to go the rainbow colors. So we're going to add some rainbow colors here. Now, I'm a little concerned about that foam. Might have a catalyst here, which is dangerous.
Oh, boy.
See if anything, nothing.
Gingerly pour.
Gingerly pour. Okay, so I'm going to add the food coloring into this one. We got a red. I'm going to let you add the next one.
Thanks.
I'm going to take the next. And Sarah Gulch down here is going to help us with the other. So
Hi, Sarah.
we're just adding food coloring. We've already got the soap in there. And this is a generous pour of food coloring, probably more than you'd ever have at home. Okay, I think we're all set up. Now, you saw what happened with that ball of foam. You're probably not going to want to put this microphone, which is probably pretty expensive.
I'm going to set it down.
Be careful with that.
Sure.
We each have 2 catalysts. We're going to do a little countdown. You're going to take 2 catalysts, and you're going to pour quickly into there, okay?
Before we do that, I just want to go over the basics. If you're heading on down to the Imagination Station, here are the hours on your screen. They are downtown, of course, at One Discovery Way. And if you live in Lucas County, the kids get in free with a paid
We'll fast
adult
forward to the good part.
loudly
Yeah,
as we do so.
Let me hand these to you.
Okay,
I'll
thanks.
take the tops off
Do the
for you.
hand off.
Do those,
All
and just
right.
hang on 1 second. Let's make sure I have mine ready, because once we do this, there's no stopping. This is
This
kind
is
of a one and done kind of thing.
One and done. This is the only
I've
shot.
got 2, Sarah's got 2, you've got 2. You know
All
what?
right.
These are a little bit lost.
Top me off
I'm
there.
gonna top you off with extra catalyst. Okay, I'll get rid of that one. All right.
Okay, setting down the mic now.
All right.
Okay.
So here we go. Elephant's toothpaste. 3, 2, 1, pour.
Step back.
Hey! All right. So, again, 35% hydrogen peroxide. We're using sodium iodide to catalyze the reaction. We added some food coloring. All those bubbles are filled with oxygen gas. It's just a classic.
It's a brightly colored mess. Take a look on the ground too here. Hopefully this will be...
Alright, so that was an example of a gas formation. The second clue that tells us if a reaction took place is if a solid formed. So if there's a solid formation.
G'day, I'm Jacob from Make Science Fun. Today I'm doing the classic lead iodide precipitation reaction. Oh, wow! In the glass below, I've got a clear colourless solution of potassium iodide, and now I release into it a clear colourless solution of lead nitrate. Both potassium iodide and lead nitrate are soluble in water, but when they mix together, they form an insoluble precipitate called lead iodide. The yellow lead iodide forms a suspension and slowly sinks to the base. Well, thanks so much for joining me today, and I'll see you guys soon. Bye.
So when he mentioned precipitate, a precipitate is all the chunky stuff. So all that chunk stuff is a solid. So what was done here is there was a clear liquid mixed with another clear liquid, and it combined and it made a yellow solid. So that is a clue that a chemical reaction took place because a solid was formed. The next clue that a chemical reaction takes place is if the temperature changes.
So we all love sports. Just sometimes not as much. If you've ever had a torn muscle or a twisted ankle, you know that it feels a whole lot better when you put one of these ice packs on, right? And other times when our muscles tense up, we apply heat packs instead. But have you ever thought about what happens inside of these packages? Alright, so the thing that makes heat packs and cold packs actually work are examples of reactions in chemistry we refer to as exothermic and endothermic reactions. An exothermic reaction gives off heat, while an endothermic reaction pulls heat from the surroundings and therefore becoming cold. To do these two experiments, these are the things we're going to need.
Some kind of cold salt, for example ammonium nitrate, water, sodium acetate trihydrate, beakers and the lid, spoons, thermometer, a large beaker to use as a water bath, and a hot plate.
Alright, we're going to start with the cold pack. Inside this pack we have the two chemicals already, but they are separated from each other. We have ammonium nitrate, which is a crystal, and we have water, which is obviously a liquid. When we break in the membrane, the two chemicals will mix, and the ammonium nitrate will dissolve in the water.
And we can do this same reaction here in the lab. Start by pouring about 100 milliliters of water into a beaker, which will simulate the plastic bag. And then we will just add and quickly dissolve about 10 teaspoons of ammonium nitrate in the water.
You will really be able to feel this when you try it yourself. You just put your hand on the beaker and you can feel how cold it gets. And you can try it with different salts. For example, normal table salt, sodium chloride, works. But the thing is that there is a difference in the temperature change that you will notice. So why do you think that is? Well, it's something for you to think about. So now we're going to put this one away, and we're going to move on to our second reaction, the exothermic reaction. For this reaction, we will start with a chemical called sodium acetate trihydrate, which is essentially sodium acetate with 3 water molecules bound to it. Let's do it.
First, heat up a water bath to about boiling temperature. Then add a few spoons of sodium acetate trihydrate crystals to a smaller beaker. Put the beaker in the hot water bath and wait for it to melt. You may have to add some extra water as the salt is getting close to melting. And when all the salt is melted, make sure there are no solid crystals left, not in the solution or on the glass. Then carefully take the beaker out of the water bath and let it cool to room temperature.
Yep, the solution is now at room temperature, and we have what is called a supersaturated solution of sodium acetate trihydrate. Let me try to explain what a supersaturated solution is.
A supersaturated solution of sodium acetate trihydrate actually contains more dissolved sodium acetate trihydrate than you would normally be able to dissolve. And this was made possible because we prepared it on the hot plate.
Basically, at around 54 degrees Celsius, the salt that is now dissolved in the solution wants to go back to a solid crystal state. But it won't happen until something disturbs the solution. So you might have seen that in some hand warmers or heat packs, you have to snap something inside of them to actually turn on the heat. And we're not going to do that, but what we're going to do is we're going to drop a crystal of sodium acetate trihydrate into the solution to create that disturbance and see what happens. Check this out. That's one of my favorite experiments. The salt is back to solid and the beaker definitely warm. Exothermic reaction. So now we've done the reactions that happen both inside an ice pack and a heat pack. But think about this one. Why do you think the pain goes down when we put an ice pack on our injury? The science behind this one is actually pretty cool too, so I suggest you look it up. Alright, that's all we have today. Good luck, have fun.
Alright, so then our last clue that a chemical reaction has taken place is if the color changes. So you saw a lot of examples of these, and it doesn't count if you just add food coloring. So it has to be something where, for example, you have two clear liquids that you combine them together and they turn a brand new color. So that is an example of a chemical change, that the chemical reaction has taken place. Right, so just to recap, if a gas forms, if a solid forms, if the temperature changes or the color changes, all of those are examples or clues or indicators that a chemical reaction has taken place. So there are some words you need to write down. So at the bottom, please write words to know and then write down these 3 words. Exothermic and endothermic was talked about when he talked about temperature change. So for ice packs and heat packs, an exothermic reaction is where energy is released. So that is an example of a heat pack. So we mixed together those two chemicals, they reacted and they got really hot. So exothermic energy exits, exothermic energy is released. So that's kind of a good way to remember it. So think of when I made hydrogen gas. I mixed a couple things together and I had to set it down because the beaker got so hot. It was a very exothermic reaction. Endothermic is a process in which energy is absorbed. So energy is being absorbed from the outside and it makes it very cold. Energy is entering. So endothermic, entering, energy is absorbed. So with the cold pack example, it's getting heat from the outside, it's absorbing that energy and producing a cold temperature. A precipitate is when we discussed a solid formation. So precipitate is just the name of that solid that is formed in a chemical reaction. Alright, and that's all of the notes for today. Hope you enjoyed this fun little tutorial, and good luck!